So we are talking about, listen up, integrating inverse trig functions. All right? That's important. You better write down the formulas.
All right.
So the first one is this. When you have an integral in the form du over a squared minus u squared, this gives you x and u over a plus c, right? So you have these three forms that I gave you.
Is it on our...
It's on your stuff.
Oh, okay.
Okay, now the question is this. You need to understand that u is a function of x. Okay, and a is just an integer that is greater than 0. But now, how do you apply these formulas? You have to figure out how to identify them, right? So if you look at the first problem there, the very first problem is already hard, you know, when I'm looking at it. So you have 1 over x square root of 4 squared minus 1 dx, right? If I look here, if you look at it, 3 separate forms,
then you gotta use the last one.
The last one, but is how you use it is the question. It's not, I'm going to use the last one. Yes, it is, but...
Okay, so A would be 1.
A would be, okay, that's fine. A would be 1.
U would be 4x.
That's not right.
Right? Oh, U is x, sorry. It's x.
U is 2x.
U is 2x, right? But the problem is this, there's things you can do here, right? U is supposed to be 2x, right?
That means,
because guess what? If you look here, if U is just x, what should be U squared? X squared, but here what do we have? 4x, right? 4x. So that means there is a problem somewhere. So this has to be what? 2x. So that means I'm going to rewrite this integral, right? I can change it. I can make my life easier. And if I turn this into a 2, what do I have to do here? Turn that into a what?
I'm so confused. Why would it even be 2x?
All right, look.
The 2?
It can't be just 2. Look, again.
Brother.
What do I have here? I have u, and this has to be what? U squared, right? If u is just 4x, that's not going to happen. Because I need to transform this. Let me rewrite this expression for you. This is x over what? 2x, the whole thing what? Squared minus 1 squared, right? Because 1 is 1 squared, correct? So now, u is now what? 2x. Because 4x squared is 2x, the whole thing squared. Do you see what I'm talking about? You see it?
Yeah, but isn't the square just connected to x? Like, why is it connected
To what?
So you're just rewriting 4x.
I have to rewrite it so that way I can match it up with what I have here.
Okay.
Right? Now the problem is this. Even here, I'm still not done, right? Because this is u and this has to be u squared. But if you look here, this is x, right? This is x. So I need to turn this into what? 2x. So now what I do is this. If I turn this into a 2, I have to I have to multiply this by what? 2 as well, right? So I'm going to rewrite this. So that gives me 2 over 2x square root of 2x squared minus 1 squared, which is now what we wanted. Now we have exactly what we needed here. Okay? So now I can apply my formula.
Hold on.
So u is 2x and a is 1. So now we can just go ahead and then apply the formula, right? So that gives me 1 over a, which is 1 over 1, because a is 1, arc secant of u is 2x over 1, right, plus c.
What is under u equals 2x?
A is equal to 1, that's a, right? A is equal to 1.
So u equals 2x and a equals to 1.
And then you just apply the formula. This is really tricky. This is where we have to be careful because we have to be able to recognize a pattern. If you don't recognize a pattern, then we have a big problem. Good. All right, so the next problem is going to involve some more transformation. Again, we have to be careful here. So let me write that down. Can I erase this?
I'm sorry to interrupt you. Those of you in the AP class, could you communicate with the rest of your classmates? I opened it up for one more day, so you have to do it by noon tomorrow. It's not Sabrina or Adrian, but there's Mason, Emma, and I think Josh.
Yeah.
I want to know for sure.
You want to fix the group chat?
Thank you.
Okay.
Oh my.
I thought this was
Who was that?
That was Arnold for them. She's like, my bad.
That's gonna be start mode.
Honestly, there's no way out of here.
Alright, so now look. Now we have a second one, right?
No.
So if you look here, which one do you think this matches up to?
One.
The second one.
The first one, right?
Oh yeah, the first one.
The first one, but now we have to do some transformation, right? We can't just apply it regularly. Can we apply it straight up? No. Because if I look here, right? If I let u equals t to the 4, what's du? T cubed, right? So what can I do here to make my life easy? I'm gonna change this again. I'm gonna rewrite this. So I'm gonna have t over what? 1 minus t squared because I want to make sure I get to this point. So that way I can apply my formula dt. All right? And this is like 1 squared because a squared minus u squared. Now do you see how it works?
Yeah.
If u is t squared, right? du is what? 2t dt, right? So if you let u equals to t squared, du is 2t dt, right? And dt by itself is what? 1/2 du, right? So if I was to do that, so because now it matches up with what I have here, right? You see what I'm talking about? So now let's not forget that we have a 2 there if you're gonna apply this formula because that's extremely careful. We have to be extremely careful, right? We have to be able to do that. So now we can go ahead and apply our formula, right? So I'm gonna have a du by itself, which this is t dt is du over 2. So that's gonna give me 1/2, right? Arc sine of u, which is t squared, right? Over a, which is 1, plus c. So that's gonna be our solution here. Okay, so
how did you
again,
get how did you get the 1/2?
1/2 because du is 2t dt.
Uh-huh.
So t dt is 1/2 du. So I need to make sure I put a 1/2 next to it. Okay? If I don't do that, then it's gonna screw my numbers up.
I don't understand that. I'm gonna be
Well,
honest.
look. What do I have here?
T D.
dt. That t dt is equal to what? du over what? 2.
Oh, okay.
Right? So that's why I have to put a 1/2 there. Right? That's why I have a 1/2.
Okay.
Again, this is a really tricky
It's just a regular problem if you put the 1/2 in front of it.
1/2 in front of it. Okay? It's a little bit tricky because you have to recognize the patterns. That's the only difference here. That's why a lot of people don't like the trigonometric inverse integers because there's a lot of patterns that we have to recognize. Okay? Now the very next one, can I erase this? Are you still writing this down?
No, I'm good.
All right. Now the next one is a little bit easier.
Just u is 2x.
I don't know. We find that out. So I'm just gonna do it like regularly. I'm just gonna have 1 over 1 plus 4x squared, right? dx. Alright? So obviously which one do you think that matches up to?
The second one.
The second one, right? But now again we have to rewrite this so that it makes sense to us, right?
So it could be 2x.
Yeah. So it's gonna be great. That's great. 2x what squared, right?
Yeah.
And then 1 square here dx. But now if you look, if you let u equals to 2x, right? du should be what?
D
2 dx, right? So you have to divide it again by what? 1/2. You see it?
Yeah.
So now we're gonna have u is 2x, right? A is 1, so this is gonna give us 1/2 again. Arc,
Wait. There's 3 halves to 0.
Yeah, don't worry about it. I'm not really worried about those. I just want to treat this as a
Yeah, but on
regular.
the AP test, we were gonna have to worry about.
Yeah, so what is
Yeah, we will do that. Don't worry about it. But I'm more worried about getting this first, and then we're gonna apply that later on, right? So let's do that. This is 2x, right? Over what? Over 1, right? Now plus c. Now suppose you have your, what do you have here again? Square root
Wait,
of what?
why'd you put the square to both?
What do you mean?
Why is 1 squared?
Here?
Yeah.
Because I'm trying to make it look like this.
It's the same as just 1.
1 square is 1, but I want to make sure it matches up to that so you
Okay,
see
yeah,
what's
yeah,
going
yeah,
on,
okay.
right? So now if you have, let's assume that you have the same problem, but now you have,
Wait, but hold up. You put the 1/2 arc tangent, but isn't it going to be 1/2 times? Oh wait, it's 1 over 1, so it doesn't matter, right?
Yeah.
So it just gets rid of it.
I mean, at least now you're getting it, though. Like, since he knows times 1 and this.
Do you have any idea what he's doing?
No, I haven't been locked in at all. Maybe you should.
All right, now watch this for a second, right? So once let's say I added the square root of 3 over 2 and then 0, right? My answer will be the same, 1/2 arc tan
Oh, you just plug
2x, right? Now we have it between what? Square root of 3 over 2 and then 0. Now you just gotta go in and do the 1/2 arc tan 2 square root of 3 over 2, right? Minus 1/2 arc tan 0 times 2, 2 times 0, right? So put that in your calculator and whatever it gives you is the answer. Okay? So that's how you would solve that. All right? Does that make sense?
Yeah.
This is a really, I know, this is a really difficult.
So you can put arctangent in your calculator?
Yeah. Arc 10 in your calculator looks like this. This one. Arc 10 is 10, -1. Okay? That's the key. And arc sine is sine, -1. And then arc secant is secant, -1. That's what the key is on your TI-83. All right? That makes sense?
Yeah.
All right. So now there's another problem. Kevin, I want you to help me solve this one.
Alright, I
Alright.
got you.
The next one. So I'll write it on the board and see if you can recognize the pattern. So we have sine x, right? dx over 1 plus cosine square x. So what do you see here? Which one do you think you're going to use?
The second one.
The second one, all right? Second one. So u is going to be what?
So let's make u, yeah, cosine.
Cosine x, right? And du is what? If u
Negative sine.
sine x. So that means when you write it, you're going to have to put a
it's
what?
gonna have to make it negative.
Negative. There you go. That's it. You see how easy it is once you recognize the pattern? So now what's the answer?
It's gonna be negative 1 over, or just 1 over 1.
Mm-hmm.
Arc,
Mhm.
tangent,
Mm-hmm.
sine, or cosine x
Mhm.
over 1 plus c.
Let's see. Right? That's it. So once you recognize it, because you realize that the derivative of that is sine x tan x, because it's negative, you have to make sure you put a negative.
Okay.
And that's it. All right? So that's how this is going to work. So what I'm going to do is I want to stop here, and then tomorrow we're going to pick up and do the completing the square, because that's a different one. So I want to give you time to like work on several problems like this today, and then tomorrow we're going to do the completing the square, which is it's the same thing but a different section.